Hello and welcome to this new episode of Free Science 365. Today's challenge is Zeno's paradox. Of course, I'm talking about Zeno of Elea, who was born in 495 BC, and he was a pre-Socratic Greek philosopher. And his paradoxes, about 40 of them, but we have 11 only with us. The 11 that we have are thanks to Aristotle. So about a century later, Aristotle wrote his book called Physics. And in that book, he described his paradoxes. Even Aristotle was influenced by Zeno of Elea's paradoxes. Also, Bertrand Russell, a great English philosopher, described Zeno as immeasurably subtle and profound. One of the most famous paradoxes of Zeno is the paradox of dichotomy. Now, dichotomy comes from two Greek words, dicho, which is two, two, and tomy means cut. So you cut something into two parts and it becomes dichotomy. Zeno and his dichotomy paradox is mind-boggling. It's very simple, and we know it should not be true, but it is true, and that's why it's called a paradox. And I'm talking about Zeno's paradox called Achilles and the Totes, or as we call in India, tortoise. So the Achilles and Totes paradox is kind of amazing. Now imagine they are going to race with each other. You have Achilles, the greatest runner. So Achilles is about to race with a tortoise, and as we all know, tortoise is a very slow animal. So he is given a head start of 100 meters. So Achilles is at the starting point and the tortoise is at 100 meters point. It's a 1 kilometer long track. Now the question that Zeno poses is, will Achilles ever be able to reach the tortoise? And the answer is yes, Achilles will reach the tortoise in no time because he's the fastest runner in the world. But here's the logical problem that Zeno poses. So, according to Zeno, this task is infinitely unlimited. What do I mean by that? Well, you can divide the action of Achilles running from the starting point till the tortoise into infinite number of steps. What does that mean? The first step is Achilles covers half the distance. Then he covers half of half the distance, which is 1/4. Then he covers half of that, half of that, half of that, and he keeps on dividing the distance between Achilles and the tortoise infinite number of times. So you can divide this track, the distance between the tortoise and the Achilles, into infinite number of steps that Achilles has to cover. And the question that Zeno poses is, how can you finish a task with infinite steps in a finite time, in a finite amount of time? And that is the paradox. So the challenge is, can you solve this paradox? Again, logically speaking, this makes sense because in real life we know that Achilles will eventually cross the tortoise. But how can we convince ourselves and others that it's also logically possible to finish a distance that is divisible infinitely in a finite amount of time? And that's the challenge. Alright, welcome back, and thank you for picking your brains on this amazing paradox. Now, we can solve this paradox in two ways. One is the mathematical, the otaku, the nerdy way of solving it, but there's another way, which is, everyday language way of solving the problem. Again, let me just paraphrase the problem. How can Achilles finish this infinite number of tasks in a finite time? And the answer was actually described by Aristotle when he wrote in his book Physics, when he talked about Zeno's paradoxes. He then reasons that actually there's a difference between can and is. Now, what is can and what is? So, if something can be divided into an infinite number of steps or parts, doesn't mean it is divided. So there is a very minute nuance between what can be done and what is. And that's the difference. And that's how Aristotle tries to reconcile the so-called paradox posed by Zeno. If something let's imagine, okay, let's take this pencil. If this pencil can be divided into infinite number, you can cut it into half and then cut that half into half and then half and then half. Logically speaking, we can, but it is not divided. It is actually finite. Similarly, Achilles' distance, it can be, logically speaking, divided into smaller and smaller segments of space, infinite number of times, but in reality it is not divided, and that's the everyday language solution to this problem. And by the way, there is actually a limit on how small can something be. For example, the distance between Achilles and the tortoise, can we keep on dividing it into half and half and half and half? And turns out, actually, there is a limit to how far we can go dividing a length into half and half and half, and that limit is called Planck's length. We are talking about the minimum, the smallest length that can exist in our universe. So physically, there is a limit to how small you can divide something into two. Similarly, there is also a limit on the time. So the time that you need to cover this distance is also the minimum time. So you cannot keep on dividing time and distance further and further into half. So there is a physical limit to that. Of course, Zeno in his time had no way of finding that, but that further puts a limit on Zeno's paradox. In our universe, we have limits on everything. Logically, you don't have a limit. For example, you can always increase the speed by 1 meter per second, but actually there is a limit. And the limit of speed in our universe is the speed of light. And if you remember, we measured the speed of light in our last experiment. If you haven't watched that video, please watch it here. Click this link and you'll go to that video. So that's the limit of speed. Nothing can go faster than that in our universe. So there are limits. Even though logically I can say, well, instead of 300 million meter per second, why can't I imagine a speed of 600 million meter per second? Yes, we can imagine. Again, it's can versus is. We can imagine a speed of something going faster than the speed of light, but there is nothing that can go. So we can divide something into an infinite number of smaller and smaller portions in half and half, but we do not have something divided this way. So that's how you can solve this paradox using non-mathematical language. Now let's get into mathematical solution of that, and for that I'll be needing our trusty whiteboard here. Now again, if you're not into mathematical things, you can simply stop watching this video from now on. But if you're interested in how to solve Zeno's paradox using simple mathematics, I encourage you to keep watching, because it's not higher mathematics, it's simply multiplication. Even though we have an infinite number of steps, we can actually find a finite solution to an infinite number of steps. And here's how it goes. Now, let's solve Zeno's paradox using simple mathematics. So here we are talking about this line. According to Zeno, this person, let's say this is Achilles. First, he covers half the distance. Then he runs up to this distance, which is again half of half, 1 by 4. And then again half of that, 1 by 8. Half of that, 1 by 16. Half of that, 1 by 32. And so on. It will get smaller and smaller further. But you can logically keep on dividing it into half. And now let's imagine that Planck's length does not exist. So let's imagine that, yes, you can keep on doing it infinite number of times. But we know in reality that this person has actually covered this whole distance in a finite amount of time. But Zeno says you can't cover that in a finite amount of time. But we know he has covered it in a finite amount of time. So how do we solve this paradox mathematically? Well, it's very, very simple. So this distance is half d plus 1 by 4 of d plus 1 by 8 of d plus 1 by 16 of d plus 1 by 32 of d. And it will keep on happening up to infinity. And that can be a little bit intimidating, but here's a very simple trick. And that's actually what mathematics does. why I love mathematics is because I see it as a tool to solve a puzzle, to solve a problem. And so it becomes much more engaging, much more interesting for me instead of just memorizing and mugging the numbers. And that's what we are going to do here. We are going to apply a simple trick. And that trick is multiply this side by half. And so you have to multiply the other side by half as well so that equality can be maintained. So half times 1 by 2 d, half of d, plus 1 by 4 d, plus 1 by 8 d, plus 1 by 16 d, and so on, plus 1 by 32 d, until infinity. And that's the only small thing we need to do. Now let's look at the answer. So you have d by 2 here equals half times half of d. So when you multiply 1 by 2 by 1 by 2, 1 times 1 is 1, and 2 times 2 is 4. So you have 1 by 4d plus 1 times 1 is 1, 2 times 4 is 8d, plus 1 by 2 times 8 is 16d, plus 2 times 16 is 32d, and so on until infinity. Now, this is amazing. Why is it amazing? Well, let me show you. If you look at this number, what you find is 1 by 4d, 1 by 4d, plus 1 by 8d, plus 1 by 8d, plus 1 by 16d, plus 1 by 16d, plus 1 by 32d, until infinity. This thing and this thing are same. So instead of this thing, you just have to implement this. So finally d, okay, d equals 1 by 2 of d, half of d, plus this whole thing turns into a finite number, the distance, this distance, d by 2. Isn't that amazing? So actually, by cleverly multiplying both sides by half, we changed an infinite number of steps into a finite number. And that is amazing. So this solves the dichotomy. Yes, half of d and half of d is actually d. So d equals d. And even though this side of the equation has an infinite number of steps, you can actually measure those small amounts of infinite number of steps into a finite number. And so this here, this equality shows that there is no paradox. It actually solves the paradox. Similarly, we can sum up an infinite number of time divisions into a finite time. What does that mean? So let's imagine this person, Achilles, covers this distance, d, in t seconds. So what we can do is we can just substitute d with t. So we can divide this into an infinite number of smaller and smaller time divisions and distance divisions, but in reality, all of that mathematically we can prove that it is finite. So this is can be divided, but it is finite. It can be divided into infinite number of divisions, but it is not divided. Divisible, not divided. And that's how we can solve the Zeno's paradox mathematically. So that was today's science experiment, or should we say that was today's paradox. So that was today's paradox. I hope you enjoyed it. Thank you for watching. And as always, please share, subscribe, comment, and watch my videos. And I'll see you in the next one. Until then, bye-bye.